Hi there. Today in chemistry, we're going to be learning about doing stoichiometric problems that involve a limiting reactant. I am making this cartoon to illustrate the steps because many students really struggle with this concept. So I wanted to make a resource to help you through any issues you may have when solving problems of this nature. I encourage you to refer back to this video often and watch it whenever you need a refresher on how to solve these problems. I hope it helps. What is a limiting reactant problem? Let's say we want to make cheeseburgers for a party. What ingredients would we need to make one cheeseburger? One bun, one meat patty, and one piece of cheese. You open the fridge and find that you have 5 buns, 7 meat patties, and 10 pieces of cheese. How many cheeseburgers can you make? Well, with the amount of buns you have, you could make 5 cheeseburgers. With the amount of meat you have, you could make 7 cheeseburgers. And with the amount of cheese you have, you could make 10 cheeseburgers. So the amount of cheeseburgers you can make is 5, because you will run out of buns after the 5th cheeseburger. In terms of chemistry, we would think of buns, patties, and cheese as the reactants, and the cheeseburger as the product. So the bun is our limiting reactant because it is the ingredient in the chemical reaction that will run out first. It limits the extent of the chemical reaction. Once the buns are used up, the cheeseburger chemical reaction stops because no more cheeseburgers can be made. The leftover meat and cheese will not be involved in the cheeseburger party and will not get used in the chemical reaction. The leftover meat and cheese are said to be in excess because there are more of those ingredients or reactants than can be used in the chemical reaction. How will you recognize a limiting reactant problem? So far, when we're doing calculations involving a chemical reaction, I give you the mass of one of the reactants, and you use multiple ratios of the balanced chemical reaction to figure out either the quantity of another reactant needed to complete the reaction or the amount of product formed. The key to limiting reactant problems and how you will recognize them is that you will be given the amounts of 2 reactants. So as soon as you see a problem where you are given the masses of 2 reactants in a chemical reaction, you should start thinking you will be doing calculations based on a limiting reactant problem. Okay, now let's get to solving a limiting reactant problem. Think back to our first lab when you ignited a piece of magnesium with a match and produced a bright flash of light. What happened in that reaction is that elemental magnesium reacted with oxygen in the air and produced magnesium oxide. The first step to solving limiting reactant problems is to balance the equation. Our reactants are magnesium and oxygen. Remember, oxygen is a diatomic element, so its chemical formula is O2. Always remember your diatomic elements. The product in this reaction is magnesium oxide. The second step is to convert your known masses to moles. So let's say we have 5 grams of magnesium and 10 grams of oxygen. As always, we convert those amounts to moles. Remember to carry all of the digits on your calculator right through to the very final answer. Now convert the mass of your second reactant, which is oxygen, and say we have 10 grams of it, also to moles. Step 3. Now we find out which is the limiting reactant, and this is generally where students have trouble, so pay attention. You need to find out which reactant will run out first, thus limiting the chemical reaction. There are a few ways to approach this problem, but the method we will be using is to arbitrarily choose one of the reactants and use the actual molar amount that you have in order to figure out the theoretical amount of the other reactant that you would need in order to complete the reaction. So we'll use the actual amount of one of our reactants and then use the multiple ratios from the balanced equation to figure out the theoretical amount of the other reactant we would need. So the math and the process here isn't new because you're getting familiar with multiple ratios. It's just that now there is this extra step.
Created using Powtoon.